Let me ask you something. If you had to push 1 million cubic yards of dirt and your entire profit margin depended on how fast and how efficiently you could do it, what machine would you trust? Because for decades, four of the biggest names in heavy equipment have been quietly fighting a war over exactly that question: Caterpillar, Komatsu, Liebherr, and John Deere. And the battlefield? The crawler dozer. Specifically, how do you build a dozer that pushes like a beast but also moves fast enough between cycles to actually make you money? Sounds simple. It is absolutely not simple. And today we're going to break down exactly how each of these companies answered that question and why it matters to every operator and owner watching this right now. Before we get into the brands, let's talk about the problem, because this is actually a fascinating engineering challenge that most people outside the industry never think about. A dozer has one job: push dirt. But pushing dirt isn't just about raw power. It's about cycles. You push, you reverse, you travel back, you push again. And the guys making money in this industry, they're not just pushing harder than everyone else. They're completing more cycles per hour. So naturally, manufacturers started asking, what if we made the dozer faster? Faster travel speed means more cycles means more productivity means more money. Simple math, right? Except, here's where it gets complicated. Speed destroys undercarriages. And if you've ever had to replace a dozer undercarriage, you already know that bill will make your eyes water. We're talking tens of thousands of dollars, sometimes more. So the real engineering challenge isn't just building a fast dozer, it's building a fast dozer that doesn't eat itself alive. And that is the problem that Caterpillar, Kamasu, Liebherr, and John Deere have each been trying to solve, in completely different ways. Let's break them down one by one. Let's start with Kamasu, because honestly, Kamasu deserves a lot more credit than they get in American conversations about dozers. Their answer to the speed problem was something called the lockup torque converter. Now, if that sounds technical, stay with me, because this is actually really clever. On a normal dozer, power flows from the engine through a hydraulic torque converter before it reaches the tracks. That torque converter is great for pushing, it multiplies force. But when you're just traveling between push points, it's inefficient. It generates heat, it wastes fuel. Kamasu said, what if operators could just bypass it? At the push of a button on models like the D65 all the way up to the D375, operators can switch to direct mechanical drive. Engine power goes straight to the final drives, no hydraulic converter in the middle eating up energy. The result? About 30% better fuel efficiency during travel compared to machines without lockup. 30%, that is not a small number. Over the life of a machine, that is a serious amount of money staying in the owner's pocket. But Kamasu didn't stop there. They also developed what they call the plus system, parallel link undercarriage system. The whole idea is to distribute wear evenly across all undercarriage components instead of hammering the same parts over and over. Kamasu claims this reduces undercarriage maintenance costs by up to 40%. And here's the part operators really love. It allows close to 100% usage of components before replacement, meaning you're not throwing away parts that still have life left in them. That's not just engineering, that's economics. Kamasu looked at the problem and said, we can't stop wear completely, but we can make sure every dollar of that undercarriage gets fully used. Smart. Now, Liebherr. And this is where things get really interesting, because Liebherr took a fundamentally different philosophy to this whole problem. While everyone else was still working within the framework of traditional mechanical drive systems, Liebherr went hydrostatic across their entire crawler dozer line. So what does hydrostatic drive actually mean for an operator? It means infinitely variable travel speed, no gear shifts, no steps, no notches. You want to go 2 miles per hour? Done. 4.7 miles per hour? Done. All the way up to 7.5 miles per hour. Smooth, continuous, precise. And counter-rotation, the ability to spin the machine on its own axis, is built right in. For finish grading work, for tight job sites, for precision applications, that is a massive advantage. Take the Liebherr PR376. This machine doesn't just move dirt, it gives the operator a level of control that traditional mechanical drive systems simply can't match. But Liebherr didn't just focus on the drivetrain. Their Generation 8 dozers come with what they call operator assistance systems. There's free grade, which actively stabilizes the blade so the operator doesn't have to fight it, and 3D grade compatibility, full GNSS machine control compatible with TopCon out of the box, and ready kits available for Trimble and Leica. So you've got a machine that drives smoother, turns tighter, and can be guided by GPS with millimeter-level accuracy. Liebherr basically said the future of dozing isn't just about power, it's about precision, and they built their entire product line around that idea. Now, Liebherr is a European company. They don't have the same North American dealer network as Cat or Deere, but for contractors who've run one, the conversation changes fast.
John Deere. And look, people either love or roll their eyes at Deere in the dozer space. But on the engineering side, specifically for their largest machines, the 950K and 1050K, they've done something genuinely impressive. The suspended double bogie undercarriage. Here's the problem it solves. When a heavy dozer runs at speed over rough terrain, vibrations travel straight up through the undercarriage into the operator's station. Over a long shift, that is exhausting, and exhausted operators make mistakes. More importantly, those same vibrations are hammering every component in the undercarriage with peak stress loads. Deere's suspended double bogie system adds a second layer of bogies with new isolators and refined geometry. The result? Up to 75% reduction in peak vibrations at the operator station. 75%. Your operator feels less fatigue. They work more accurately. They last longer through a shift, and the undercarriage components take less peak stress, which means they last longer too. But Deere also attacked the wear problem directly at the material level. They offer what's called extended life undercarriage, track chain bushings coated with something called SC2 coating. This proprietary coating forms a hard shell over the bushing surface. According to Deere, it delivers up to twice the wear life of standard bushings. Double. And both the extended life and heavy-duty undercarriage options use sealed and lubricated track, what Deere calls salt, with an oval track design that minimizes the flex points where wear actually originates. So Deere's answer to the problem was essentially make the machine kinder to its own components from the ground up. Smarter geometry, better materials, less stress from the start. And then there's Caterpillar, the name that still dominates the conversation whenever anyone in North America talks about dozers. Cat's flagship large dozer, the D11, is the machine you'll find in the world's biggest mining operations. And at that scale, the engineering focus shifts slightly. You're not just worried about cycle times anymore. You're running these machines in some of the most abrasive, brutal environments on Earth. Coal mines, iron ore, copper. Cat's approach for the D-Series has been relentless refinement of bushing lubrication and seal protection, because in an abrasive mining application, contamination is the enemy. The moment fine particles get into your track pins and bushings, wear accelerates dramatically. Cat's engineering focus on keeping those seals intact, keeping lubrication where it needs to be under extreme load and extreme contamination, that's where they've invested. And then there's the dealer network. This is something you can't put on a spec sheet, but it is absolutely part of the Cat value proposition. Cat works directly with mining customers to optimize ground-engaging tools, the actual cutting edges and end bits for specific material conditions, getting more tons per hour out of the same machine just by dialing in the tooling. That's the Cat model. Not just sell the machine, but support the entire operation. Is the D11 the most technologically advanced dozer on this list in terms of drivetrain innovation? Maybe not. But is it the most proven, most supported, most trusted machine in large-scale mining on the planet? The sales numbers say yes. So who wins? Honestly, and I know this might be frustrating to hear, there is no single winner. And I actually think that's the most important takeaway from this entire breakdown. If you're running a coal mine and you need bulletproof reliability with a service network that can reach you anywhere on Earth, Cat D11. If you're doing high-cycle earth moving and fuel costs are eating your margin, Komatsu's lock-up torque converter and plus undercarriage is a genuinely compelling economic argument. If you're doing precision finish work, tight sights, or you're running GPS grade control, Liebherr's hydrostatic drive gives you a level of control that mechanical drive machines simply can't match. And if your operator comfort and undercarriage longevity are your top priorities, John Deere's suspended undercarriage and SC2 coated bushings are real, documented innovations. The truth is, this isn't a story about one company winning and everyone else losing. This is a story about 4 world-class engineering teams all attacking the same hard problem from 4 completely different directions. And the winner is actually the equipment buyer, because competition at this level produces machines that would have seemed impossible 30 years ago. Faster, smarter, more efficient, longer lasting. That's what engineering competition does. And in the crawler dozer space, that competition has never been more intense than it is right now. If you run any of these machines, I want to hear from you. Drop a comment below. Tell me what brand you're running, how many hours you've put on it, and what you think the competition is missing. Operators and owners, your real-world experience is worth more than any spec sheet. If you found this breakdown useful, subscribe, because we go deep on the machines that actually build this country. And I'll see you in the next one.